Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 298, selling pieces of wood. So hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So first things first, I'm not gonna lie, I did it in C++ because I don't trust Leetcode and Python, even though you know I love Python, but yeah, that's basically the idea. The other thing is that I'm not gonna lie, I actually misread this problem quite a bit during the contest. I didn't read the part where you can make a vertical. It has to be an entire vertical or horizontal cut. So I missed that part, and as soon as I read that, I was like, okay, this is pretty straightforward. For some definition of straightforward, sure, but yeah. And the idea here is dynamic programming. And I think this is actually I think this was I may be wrong about this, but I actually have done this problem, I think, from over what year is this now? 2022? About 15 years ago, 16 years ago, some on Top Coder or something like that, where the problem was called candy something, chocolate something, or something like that. But that said, I didn't really have to look it up or anything. I mean, I think at the time, to be honest, when I was younger, this was more challenging for me. But because I've just been practicing more on these types of problems lately, I think on this particular thing, I'm better than I was. But maybe I'm not. Maybe I'm just delusional. So anyway, side story aside, the idea is dynamic programming. There are a couple of things you have to do on this one. One is looking at the prices. And yeah, oh, I didn't even need this actually. I got rid of this. This is a very short code, to be honest, so I'm just going to go over it right now. But the idea is to just break it down. And it is really, to be honest, so I'm like looking for my drawing things. It's my first time I needed to use my drawing things in a while here, because I've been traveling. So yeah, okay. So let's say you have something like this, right? So I'm copy and pasting, hang on. Okay. The idea here is just brute force in a way. So that because you always have to make a cut all the way across for a particular piece. Let's say this is 5 by 3, right? You can think about it first as recursively. I like to think about it recursively first. 5 by 3, right? Or 3 by 5 technically, because it's height times width. So 3 by 5, right? So let's say you have some f of 3 by 5, and of course the input, right? Well, that is just equal to you just brute forcing, really. Let's say this is 3 by 1, right? What happens if we cut it this, or rather, we cut this thing right? Let me use another color real quick. Yeah, we try cutting it here where the red line is, right? And then what do we have? Well, we have a 3 by 1 piece and a 3 by 4 piece. So that's basically one thing that, you try all the, so yeah, you try to max, basically, f of cutting it by 3 to 1 plus f of 3 to 4, or, or you cut it this way, right? Now you have f of 3 of 2 plus f of 3 and 3, right? Yeah, and so forth. So this part you can figure out. And of course, this is just cutting it vertically. You can imagine that very easily. You can also cut it from left to right. And in that case, you will have, what is that? F of 1 by 5 plus f of 2 by 5, right? And that's basically really the answer for this one. There are one more observations to make. One is, well, how do you set up the cost for these things, right? For me, it's just thinking about it in terms of setting up the base case almost, right? And the base case here is that, okay, let's say how do I want to say it? Yeah. So basically, one way that I would think about it, maybe, and we can maybe rewrite this in a more clever way. But the way that I would think about it is that let me clear this. I hope that everyone understood this because I'm going to clear this real quick. I mean, I don't think this is fun. Right? Is that okay? So let's say we have this, right? And let's say we have a 2 by 2 square that's a caught in the profits or whatever it's called, right? Well, the idea here is just having a recurrence that lets me say, okay, this is 2 by 2, but it's also, we compare it to 2 by 3, 2 by 4, 2 by 5, 3 by, or yeah, 3 by 2, 3 by 3, so forth, right? Like regular dynamic programming stuff, but span it out so that, if this is the best, and in this case, it might not be, because obviously in this case you can have just two by twos in the same thing, and that's obviously more than one 2 by 2. But you can also say that let's say we have let's say we want to find the cost of a 3 by 3, right? Oh geez, these lines are hard to draw. Sorry friends. But yeah, let's say we have a 3 by 3, right? Pretend that's straight lines. Then here, and we only have a 2 by 2 square as something that we can sell. Then we just chuck these things away, right? And 2 by 2 is the maximum profit here. And now with that, we'll go over the code to really go over what I mean. Okay. So yeah, so basically here we go. Okay, what does this mean, right? This is a base case of an x by y, or height by width piece gives us prices of $2, right? Something like that. And so we set it up here. And I did, so these two parts, I hope it's understandable. Basically, the idea here is cut into two smaller pieces. I think this one is horizontally. And this one is cut into vertically, right? So these two, I hope that makes sense, is just what we went over. Making sure that I have it on screen, yeah. And so the way that I expand this part into bigger pieces is by doing this. Is basically saying, okay, right? Let's say I have a 3 by 3 piece, right? Then that is just the max profit of what we have here, or a 2 by 3 piece, or a 3 by 2 piece, right? And of course, there is a recursion to this, right? Meaning that this 2 by 3 piece, because of the magic of dynamic programming and the order that we did it, is also the max profit of a 2 by 2 piece, or a 1 by 3 piece, right? So basically, in this way, a 3 by 3 space, as a result of this, or I times j space, will return the best profit of all the numbers that are smaller than it, and doesn't, or the tiles or wood that is smaller than this piece. And that's basically what these two magic statement does. And a lot of it is just from practice and me kind of recognizing it from practice. So if you kind of miss that piece, I think it's easy to miss, and it looks easy, but dynamic programming, sometimes every code looks easy, but the logic that goes into it is sometimes tricky, and so don't beat yourself up too badly. Try to figure it out along the way. But yeah, that's pretty much all I have for this one, except for complexity. This is going to be, and this is why I changed it to C++ preemptively this time, instead of trying to be better on yeah. So when I saw this, I had this algorithm in mind, but and the algorithm is that it's gonna be O of R times C times maybe max of R times C or something like that, right? So this is going to be roughly speaking 200 cube. And when I saw that, and I know that this is strictly a little bit better because this only goes up to I and J, but I was like, I don't want to risk it with Python. Let's just go straight to C. And that is the complexity, is that this is that for time, and for space, the DP array is R times C, so it is going to be, space. And that's pretty much it. Yeah. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. You could watch me solve a live in the contest now. Okay. A little bit better, but that 4 mistake is going to cost me. That was just me being sloppy and getting on tilt. Have to control my emotions. Control your emotions and finish the problems. Height and width, okay. Okay. This is maybe too sad because of all the penalties. I could have just slowed down, but I rushed it. Can I do greedy? How many prices? There's a lot of prices. 200 by 200. Can't really do recursion. Is there a way such that okay, the entire height, okay, that makes it a lot easier. Okay, otherwise, okay, I didn't understand that. Well, that makes it possible at least. Let's see. Okay, what do we want to do? And we want to take. I don't know if this is too slow though. I think 200 cube is too slow, right? That's 8 million. In other languages it might not be, but in Python it might be. I set this up. Is this too fast? I'm not going to take the risk. I feel like I've always taken the risk before. Okay. How do I construct a TP? I feel like people know how to do this. But okay, I think I got it. Maybe not. I don't know. I shouldn't sound that confident. So what? Height. Width. And then the price. And okay, they are distinct. Okay, that's good. I guess I should set it up. Okay, and now if I guess we should start one that doesn't run. I guess actually I don't need to do it that way. I don't know why I wrote it like this. Okay, and then now dp actually max of dp. Okay, this should give me some non-zero answers, but whoops, wrong language or something. Well, this is why I run it every time, but okay, 7 and 10, which is the biggest piece, I think, so that's fine. How do I do it? Okay. No, it has to be. So, from an eyepiece. something like that. And same thing for. Oh wait, I shouldn't do it that way. And this is in C. This is J. I think this doesn't matter. Then J minus K and IK. $19.32. Come on, big money. Okay, that's good. Don't know if this is right. Hopefully it is. Okay, cool. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm and the explanation. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye-bye.